All right, so I think we got all the stuff going. This is the interest group for economics for July 8th. We're going to be talking about remarks and how it fits into the reproducibility. Shall we call it a crisis? I don't know. Let's say problem in economics. But this can be expanded to science at large, I suppose. So with that, I'm just going to toss it off to Chris and Alan here.
Yeah, because it's so hard to attempt to reproduce things that nobody even tries. But to the extent that at some future point people will try, then that's when the crisis will occur.
It's actually an interesting take on this I haven't heard before. It's like you can't tell you're in a reproduction crisis until someone tries to actually reproduce it, and that might be like 5 or 10 years later. That's great.
Yeah.
As an example, among the few examples of papers that actually somebody tried to reproduce and failed, there was a paper in the American Economic Review which claimed that a certain category of models sort of resolved all sorts of problems that had plagued the more traditional models. And it was there for like 5 years before anybody tried to reproduce it. They tried to reproduce it, of course, because they wanted to extend the work. And they basically found a bug. And, you know, most of the results kind of evaporated when you fixed the bug. So among the few examples of papers where there has been an attempt to replicate, even in the very top terms, that's what you get.
I wonder if, because this does set the context a little bit, so maybe we continue down this road a little bit, but I'm wondering, why don't people reproduce, or why aren't people trying to reproduce like great novel findings or great research as soon as it's published? And then is this like an incentives problem? Because I'm kind of jumping the answer there, but is there a way we could get people to start reproducing stuff instead of always trying to find groundbreaking research?
Reproducing things is like time consuming, expensive, and the reward, the benefit profile, not just financially, but like socially, et cetera. I mean, it is pretty weak. At least from my experience in engineering, you see a lot more emphasis on reproduction because you're doing it yourself, actually pursuant to the development and implementation of algorithmic machinery, where like the cost model is your thing breaks, blows up, crashes, or like it's immediate. And so the reproduction workflows exist as part of the core workflows because the paper results aren't the end product. As long as you're operating in a regime where the paper byproducts, the things that you publish, would then be, you know, checked by someone else, and you don't explicitly bear the risks or the vulnerabilities of your failures. In fact, you in some ways get benefits in the example you just described, right? Like the fact that the bug resulted in a powerful result, like they don't even really have that strong of an incentive to hunt down that bug. I mean, they do because eventually it gets called out and it sucks or whatever. But I think your point about an incentive problem is valid, but I view it as like a systems problem in the sense that the environments where there's like real material risk cost borne by the actors who are doing the modeling, the amount of checking and reproducibility is just higher on the balance. But again, that's more like, you know, aerospace defense controls engineering. My experience in economics came first through resource allocation problems in a more robotic setting. And so just the amount of kicking the crap out of your models that is just like default practices seems to be much higher, but you bear the risks or the costs of your failures.
With everything that you said. I will say we have two ideas about how to fix the incentive problem. One of which I think we will be in position to encourage or to implement in the near future. That one is there is a group of people connected to the Econ Art project who are trying to start a journal of open source economics. And we have discussed the idea of basically saying we will publish any reproduction or replication of results in a paper in a good journal that satisfies the criteria that the reproduction / replication is itself sort of automatically reproducible, replicable, using our remark technology that we're here in part to discuss with you. So what the person would do is to submit a remark, which the fundamental definition of which is that it is reproducible by running a script called reproduce.sh in folder. And if the person did a sort of reasonable job of trying to reproduce the results, we will publish it, whether they succeed or do not succeed in reproducing the results.
So I have a question about that, where it's just like, it's funny because on one hand, I'm like super excited, like, all right, cool. It deals with the kind of works on my machine class problem. But as I was getting excited, I was like, oh no, but what if like your reproduction is so automated that like in the case of your example with the bug in it, like wouldn't the remark contain the same bug if you really just used a script to run the same thing? So you would have reproduce the result like quite literally, but you wouldn't have like re-implemented, or like you would have, on one hand, you would have truly tested the piece of software that they had published and run the scripts to run it again, and then for reasons of strong reproducibility reproduced the results. But if there were errors, like is there a class of errors that it wouldn't see? Like and again, I'm asking it more just out of curiosity, not as a complaint.
So we haven't fully worked out how we would want to handle these kinds of submissions, but one thing I would want to require is that that there be robustness checks for the results, in the sense that you have to sort of see how your results change when you change each of the kind of important input parameters. That alone, I think, would be a pretty powerful way to discover quirks and puzzles and things like that in the results. But the main point here is, we're not going to publish if like somebody wrote a paper for a top journal and it actually is easy to reproduce on anybody else's computer. That's not really what we're looking for. What we're looking for is cases where there's a paper out there and they describe a model and they claim various results for the model, but like there's no code that anyone can manage to download and get it working themselves. And so there has to be some kind of distinct replication.
Yeah, that makes sense.
It's almost like there's different tiers of like replication and reproduction. There's the fact that there's data and code and I can click a button and produce the exact same results as the paper got. And then there's those robustness checks. And then there's probably like tiers even higher up where it's like full on replication, or you do a full code audit to just make sure there are no bugs. And each one of those acts is like incredibly valuable to the process of knowledge discovery. So rewarding those steps in varying degrees, weighting those rewards in specific ways, seems highly valuable. Seems great.
Yeah, I think diving into the question of robustness too, you hit on something that I think is just like very central to kind of going back to the engineering analogies, is that like you really know that you don't know a lot of things about the world, and so good models have like reasonably well explicitly defined the places that their assumptions are being made, and your robustness checks are various versions of like how well do my conclusions stand up to not just changing random variables, but sometimes even changing boundary condition models or other things that, again, are abstractions about the world. And you're like, okay, cool. You get successively more robust results the more you can sacrifice in your assumptions, or the more that your empirical results stand up to, again, not just Monte Carlos, not just, variations in core parameters, but even like changes in functions that represent boundary conditions and such. And so anyway, this is really cool. I want to let you guys dive in, but it's a concept that's close to my heart. So I'm looking forward to hearing about it.
Let's see. So Alan, do you want to talk them through? Alan gave a presentation about remarks at the Society for Computational Economics recently, so he could probably use that as a template for what to describe to you guys.
Yeah. I'm just going to go over sort of what we've been working on in terms of reproducibility of our own work, and show you what sort of standards we're trying to define, both for ourselves and hopefully with some uptake from the profession more broadly. And so the first thing I want to show you is a remark repository. So a remark repository is essentially a catalog of, if you go to this remarks folder, you'll see that we have both YAML and Markdown files. Right now, we're in the middle of switching the particular metadata that we're using. But if we focus on like a particular YAML file, we see that it's got a name for a different repository, and it has a link to a different project. And so the remarks repo is both just a catalog of the projects we've already worked on to make reproducible, and also a specification of what we mean by reproducibility. And so the sort of three major elements that we're thinking of right now in terms of reproducibility is a very explicitly and clearly defined environments file. This is going to tell you what version of Python, NumPy, SciPy, etc. Because oftentimes you go into a paper's zip file, because a lot of economists don't even use repos. You just download a zip file that is attached to the paper. And you have no idea which versions of which libraries, third-party libraries they're using, or even like which version of Python, which version of Fortran. How do you set it up? And it only really works on the computer that they started the project on a few years ago. And so having a very clear specification of your environment is important. And so it becomes for us a requirement. The other requirements then are a citation.cff file, and this is going straight into what you were talking about, incentives and rewards. We want people to be rewarded for the work that they put towards, especially open source economics, and so we want to assure anyone that would ever use sort of our tools that your project and your citation.cff file always go together. And so you're always going to get linked back to who did this, who did the work. And presumably when we're thinking about like the future of a journal of open source economics, this would also be a way for you to not just get like, we thank someone who wrote this project, but more so start getting citation numbers of like, somebody else used your tools, then you get like a proper citation that may go into like your academic profile and might help you get, promoted or different types of things. So the citation file is very important, and it's just going to have metadata of who the author is and what they worked on. And then finally, we want to be very detailed about what you're aiming to reproduce. If there's a particular result in your paper, you should be able to do like bash reproduce.sh, which essentially what we envision is it's a one-click reproduction of your full project. It should both install anything in your environment, and then it should generate any and all results that you consider an important contribution in your paper. And so these three elements we think of as the major components of of a reproducible project, and they're going to be part of what we're calling a remark here. And just as sort of an example of what a remark project would look like, this is a project of mine that is not part of Econ. But you see here I have citations, that file, which says, the author, the title, the abstract. Now also have a reproduce.sh, which is going to say, all my work in this particular thing is in my notebooks. So go ahead and just run the notebooks. And there's going to be environment files here, which are going to say, okay, well, what is the simplest environment and the dependencies that I have to be able to run this thing? And so that's what we're going to call a reproducible project. It should be easy to clone, to recreate the environment, and to run the results that we consider to be important. And so where we show currently the catalog of things we have working is in our website. If you go to this sort of the materials tab, you'll see like the full listing of all the projects that we have in our remark catalog. And in particular, I can show you sort of one of them where, for example, this is a paper by Chris and some co-authors a few years ago called Modeling the Consumption Response to the CARES Act. And from the metadata that is in the remarks repository, we have an automated system for the website that creates this sort of paper or project page. And it's going to have the name, the references, some other details, and it's going to have this action panel that can tell you where the source code is, if there's a dashboard, how to use it. And for example, if we click on this particular launch dashboard, we see that it launched a binder repository, a binder environment online. And because we were very explicit about our environment, we can very easily generate all the results that are in that paper, and even interactively just sort of like change the parameter of unavoidable spending reduction or duration of lockdowns. What if it lasts way more than a quarter? And you see these results update in real time. And so what we're thinking of with reproduction is also that reproduction can make our projects more interactive, both for in the way that we sort of demonstrate the novelty of our projects. We can generate these sort of like notebooks or dashboards that aren't just sort of static figures on a PDF that you read and it's sort of hard to really understand and get a good insight. You can start developing these sort of dashboards that are interactive and say, okay, well, what actually happens if I don't use the parameters that the authors did, but I change them according to my own beliefs about whatever the project is. And so because we are sort of so focused on making this reproducible, we can also make it interactive and deployable in any sort of browser. Because at the end of the day, this is running somewhere in like an Amazon server, and because we were explicit about our environments, there's no sort of ambiguity as to how to reproduce the paper. So it like automatically is reproducible both in your own computer, someone else's computer, but also in some server where you can then serve a dashboard or a notebook to your readers.
Can I ask a question? So given all this, it seems like it's also pretty forkable because, you know, there's kind of two levels of modding, right? There's modding it within the frame of reference of the paper where you're subject to the sort of assumptions that are present, which I like, you know, making them explicit and being able to use the interactive elements to make changes and see consequences, but you've still constructed a sort of frame of reference when you've decided what the parameters are and what the variable ranges are and what metrics you're displaying, yada, yada, which is, I mean, necessary. Like there's no way around that, right? That's the nature of models. But, you know,
Yeah.
as you get to this level of reproducibility and deployability of an individual object, you know, again, I'll call it a knowledge object, which has been clearly identified and has been rendered reproducible. You also then create a sort of a landscape in which a diff on that object is not just plausible, but it's trackable. So like I could, let's just say I felt like, you know, for some reason that the scale on your axis being, let's say you had a log scale and I felt like, hey, that's actually kind of misleading. I'm going to rescale it. And I made a fork where I actually had to change the code, but I changed the code in a provably small diff kind of way, and then like redeployed and got to another version of this. I mean, it sounds like this is already quite possible. I'm just kind of curious on how you see that fitting into this framework.
Yeah, certainly.
No one didn't highlight is that we had to think hard about how to balance the sort of sense that the person who creates the object is its owner with the desire to have kind of a library of the reproduced objects. And the solution that we've come up with is that remarks, and we'll change the name when it becomes a submission standard for a journal, but that the sort of canonical way for them to work is that you, the author, create a GitHub repo that you own, which satisfies the laid out requirements of what is necessary for something to be a remark. And then we fork it. And we fork it at the point at which you tell us now is the time to fork it. And then the person can keep, like, you know, make further changes, and there can be version 2.0 or whatever. But we have a frozen version of the thing that the person originally claimed. And of course that makes it, means that anybody else can fork them as well, and then they will have a coherent diff history through Git of what they changed. So.
Yeah, it sounds like the Git protocol is doing a lot of work for you there, because the Git hash, the commit hash is the actual, you know, intrinsic identity, or I guess it's not totally intrinsic because you need some context to interpret it, but like that Git hash is the thing that is the canonical identity of the version of that code that the claims are about, and so that the claims that you're making are not about forks of it. They're not about, you know, changes to it, but it kind of creates a more adaptive protocol wherein something that might be interesting is whether certain kinds of claims, again, hold true for a wide range of minor modifications. And for me, at least, that's the practical version of robustness and reproducibility. Isn't just that we've reproduced that result on that specific set of assumptions, but actually, can we find something that the qualities of the interpretation, the thing that we're looking at and saying, oh, wow, this exhibits this property, actually stands up to a variety of, you know, differently informed assumptions or questions, but that there's still again, it's moving away from the concrete, this fact about this specific simulation to this more qualitative conclusion about this family of things. And it seems like the most natural way to get back to that would be to start this process where you have a specific thing with a specific claim and it's reproduced, but then people make modifications and probe some of the same questions about the mods. And if you find a cloud of things where you get a lot of the same qualitative findings or properties that stand up to those variations, those are strong results.
Yeah. Yeah, I mean, at the end of the day, we see this ability to easily fork and modify the code as a feature. both because of, the robustness of the results can be thoroughly tested, making ideally your results more valid, but also you can sort of broadcast your results broader to a broader audience, I think. And I think also another important factor that we haven't discussed is that I think the majority of economists, even those that call themselves computational economists, don't have formal training in software engineering. And so a lot of this stuff we sort of pick up along the way. And it's a great benefit to students to have sort of well-commented code, reproducible projects from which they could sort of start in their second, third year of PhD and saying, well, I can take this model that I know is already reproducible and I can modify according to some ideas that I have. And that could be the start of a project or a chapter for their dissertation. So at the end of the day, we really think there's a ton of benefits to being able to have this reproducible structure and externalities, both individual benefits, but also externalities to the rest of the economics field in terms of
So it sounds like the reproducibility is a necessary but not sufficient condition. And some of the other conditions that you've described include the sort of provenance, so the ability to make these changes and keep track of who made them and on which artifacts, the lineages, which Git provides both the diff structure, the forking structure, the strong identity of the instantiations of the code, and the strong identity potentially of the actors as defined by their whatever identity. If you're using GitHub, then you have GitHub providing an identity system. But I guess what I'm getting at now is just like, if we take the economics of this, rather than this is about economics, but it has an economics. And so if we probe the economics of, let's call it reproducible computational economics workflows, then I see I'm trying to lay out a variety of necessary conditions and probe towards something like a set of sufficient conditions for, a phase shift in the economic incentives, since John brought it up. And I'm seeing you have the reproducibility, the reproducibility of the relative ease of reproducibility, strong identity on the instances of the code, the ability for people to both maintain ownership over their thread, which is the canonical repo, the ability to fork them and make modifications and have provenance over what things you forked, the relatively strong identity of the actors if they want it, so that they can get credit for their contributions in a basically, a more interwoven setting where families of models grow up. And you also need yeah, I guess so. It's provenance, identity, reproducibility. I don't know if anybody else has some other ideas, but I'm honestly I find this really intriguing to ask what is necessary, what might be sufficient. What other user stories have you bumped into around making it I guess your talk about the student makes me think of how do you get people to make high quality code? Well, you have them start with something that's already high quality and make minor changes while preserving let's say, if you only make a few small changes, then you only have to write documentation for the few small changes you made. And you don't have to write, an entire, basically paper worth of code documentation, and then if you change your code, have to go back and fix it, which I think is a blocker I see for a lot of people, because software engineers don't also write great documentation most of the time. You usually got to push them pretty hard to get them to focus on the documentation. Ironically, I have found researchers are better at writing documentation, but their code is worse.
Yeah. So I think the place where we have the greatest sort of uncertainty about how to make all of this work is that we're providing a public good, which needs some care and feeding and maintenance. And since it's a public good, it's always hard to get anyone to pay for it. There is, so let's see. a little more background. This Journal of Open Source Economics is the name of the journal that we were talking about trying to create sometime in the next year or two. I am, turns out, the incoming president of the Society for Computational Economics. And in that role, I anticipate that I may be able to persuade the society to be a sponsor of the journal, which will add, I think, a good bit to its prestige and credibility. Unfortunately, the society is not a fount of unlimited funds, and so the society probably can't afford to pay for the kinds of work that will just sort of keep the lights on. And the thing that that we're kind of puzzling about is whether what are good funding models for an open source, free access journal. We're not. We would very much like to avoid what some of them have done, which is that you pay $5,000 in order for your article to be published in the journal. Particularly to the extent that our idea is to try to encourage graduate students to try to reproduce the results of papers that have not been reproduced. That would be a deal breaker.
Sense. I mean, I think that just maybe for some context, I'm a handful of cross links with that set of problems, ranging from I'm the treasurer of a nonprofit that's currently trying to develop a journal as part of their offerings and figuring out the cost models and benefits for that, although it's not computationally focused, is non-traditional for reasons, and also have been involved in the open source software development communities for some time, including in and around NumFocus, hence being on the one of the chairs of this session. So the problem space that you're describing is very, very real. I think that one thing to keep in mind is that the value propositions are not like generic for all quote unquote public goods or even knowledge goods of this type. Like figuring out ways to identify specifically what's the most immediate set of benefits that will render what you're delivering, so that it saves money, time, and effort on the part of actors that have money flowing through them. And I think one of the challenges is a lot of the times in the academic setting, that would mean having to tip over into a model where, I don't know, something can come out of grant funds, but in a way that's not huge, in a way that sort of creates, and again, this isn't meant to be the solution. It's more like brainstorming, like, okay, where are there existing monetary flows, where there are costs and frictions being borne, where you can lower cost, increase qualities, and generally like establish a relation where there's a certain amount of dependency, or let's say social expectation, if not like hard expectation of compensation. Might be as simple as like maintaining like discovery services or something that someone can subscribe to that are separate from the underlying open source software, but are able to improve the UX. A lot of the like open core style business models revolve around like, hey, you can always do this for free if you want to, but also there's some things that are a pain, and if we do them for you, will you give us money? And I've talked to those at length, talked about those at length with like Travis and some of the folks from the NumFocus sort of NumPy SciPy ecosystem. Anyway, it's a fun topic. We could probably do in a whole session sometime just on.
Yeah, I was just thinking, and I would love actually. I don't know how far you're into this walkthrough of Remarks, but I love the idea of exploring the problems you're facing in terms of getting this adopted and getting reproducibility as like best practices in the space. I would love to explore those further and then like make specific calls for each of those problems, because I see, like you're saying, they're shared problems, like funding models, Yeah, I also have a lot of cross section at some organizations that are trying to build workshops around like approaching these problems and trying to find solutions through technologies and other things. And I would love to dig deeper into all of them. So I'm definitely writing down funding models for a future call.
Yeah. Well, so the other things I wanted to discuss was sort of we have been in collaboration with CurveNote, which I think so there's the Jupyter Books project and the Executable Books project, which is all open source, and they also have the MIST project. So they've made all these open source tools, but they also have created this sort of like for-profit business side to like consult on all this open source software. And we've been collaborating with them to sort of create a demo of what a journal of open source economics might look like. So I just wanted to show you that. And this is a very early demo. So we have like just a handful of like potentially what a paper might look like. And so here, for example, I can show you this, which is a project of mine, which like you can click on this and get all the information. And so CurveNote has this idea that the paper of the future isn't a PDF, but more so a computer readable, like a website, which can be interactive. So for example, here, if I click this button, and this is going to launch Jupyter Notebook instance right on the paper. And you can then sort of interact with the computational aspects of your project as you are reading your paper. So for example, here, we just have like different, for now, this is just looking at different sort of angle views of this particular graph. But there's a lot of potential that could be done here. And so like as you're reading your paper, you can hover over your citation and get the full citation without having to go all the way to the bottom. You can also just like click on the link and it should take you to the paper itself. So that's super easy for like reading the papers. And it also works with like rendering the math right on the paper in a very nice way. And it would still have like your figures and your citations at the very end. And what I think also is very interesting about this collaboration with CurveNote is that they have also allowed supporting documents, which can be as simple as just additional Jupyter notebooks that can be run. So for example, if I launch Jupyter, this is going to take me right to this Binder website, Jupyter Hub website, where I can just look at everything that I have here. Let me just. And so, for example, if I run everything here, this is already going to demonstrate the things that I was and reproduce the figures on the paper. But also, if you are in this scenario, you don't have to go to like your typical Jupyter Notebook instance. You can run things right on your article, which still gives you this like nice reading environment where you're just like you're reading a paper, but you can also just rerun everything in the results. And this is all sort of like supplementary documentation of the article. So this is something that we've been working with CurveNote as an enhancement to the Remark standard. We don't necessarily imagine that this is a requirement, but this is an additional feature that can make your project more have a bigger reach and be more interactive and instructional. So that was really the last thing I wanted to cover, and we can keep discussing
Yeah, so I really want to talk about what you're doing there because I think there's maybe it's a little further than where you're currently at, but you're starting to do something that I've been experimenting with my own team within our project. The pilot is called Blocks of Docs because my company is called Block Science and everything is about modularity. But like what you're doing, take a repo and imagine that repo contains, let's say, LaTeX files that are compilable. It contains your Jupyter notebooks, which are themselves basically like JSON files. So you could impose more strict typing on them if you wanted to, including correspondence to or references to cells within the, say, paper docs. But like, imagine now that you have this sufficiently modular, I'm going to call it template, even though template is a little bit of a strong word. You could call it a kind of almost like imposing a schema on the entire repo, some folder structure, some specific rules about how your Jupyter notebooks might be constructed and how your LaTeX is constructed that come with some tools for cross-linking them in meaningful ways. At this point, though, your repo can contain data sets and code and notebooks and whatever it is that it needs to contain. But your paper, whether it's a website, a PDF, or any other object, can be now interpreted as a view. So the Jupyter notebook that you open up, any particular Jupyter notebook that you open, is a view. The PDF is a view, the website is a view. And so like if you think about this from almost like a database design, though it's a pretty complex database in this model where you have rules about styles and templates and structures for the LaTeX, some extra rules about how you configure your Jupyter notebooks, and taking advantage of now your ability to local reference specific files, specific points in your paper, specific points in your code, etc. Again, I get this is, a little bit further along, but you're like right at the cusp of being able to say, hey, as long as you satisfy these rules in the construction of your repo and your LaTeX is done like this and your Jupyter notebook's done like that and your supporting code files are done like this and your, repo structure is approximately like this, suddenly you get like this higher order operator that can take anything that satisfies those rules and produce as distinct views from the same object. Code reproducibility runs like your remarks, paper, like production of the PDF documents, and actually websites and other things. And so the reason I really like thinking about things this way is because I feel like I'm working on, and we all are working on, things that are higher dimensional objects than the artifacts that we're used to looking at, whether it's a website or a Jupyter notebook or some LaTeX for a mathematical. Maybe I just want my proof to be in its own thing so I can go look at just that. Whatever, the way that this knowledge is organized is getting decomposed because we got so used to serializing it, like paper publications. And I'll admit this is part of the reason that after I did my PhD, I went into industry and not into academia, is because it seemed like a lot of effort was going into this sort of serialization and deserialization of these knowledge objects. And so what you're basically breaking through is the stage where you have to publish the serialized object. You could have this repo with its remarks and its code and its reproducible code elements and its mathematics and its everything else broken up into pieces and arranged in a way that the serialized paper PDF is just a view, the website, etc. And I don't know how that resonates with you, but like what you just showed me was like, aha, yes, exactly the direction I feel like these things need to go.
Resonates with us, and we have been kind of feeling our way in that direction, although we haven't made any explicit like roadmaps for going that way. One of the attractive things about the curve note setup is that it generates automatic HTML anchors that you can define the name of, so that a person can link to the growth impatience condition or whatever is the specific thing they want to make reference to in some external way. We also have a kind of I have just developed over many years of writing papers a kind of uniform structure for the repositories that contain those papers. And at a minimum, our exam example repositories that we provide, our example remarks, can be structured in all of them in the same way. So the LaTeX document needs to be in the root directory, because LaTeX is really bad at handling anything not being in the root directory. The amount of time I've wasted trying to get LaTeX to have its junk files put over here, and it's not worth it. Then there's like a codes directory and a figures directory and a tables directory and an appendices directory, all of them below the root directory, and various other kind of structural decisions like that. But there's I think probably having multiple eyes on thinking about improving that structure and turning it into something like what you've described as a kind of a template that is natural.
The pilots that we're running are the user stories, basically driving the pilots, because they're internal pilots for internal docs right now, revolve around reducing the reproduction. So when I think about your paper and let's say the paragraph describing something and the documentation of a particular, let's say, block of code or a set of assumptions or a figure, like there's a certain amount that I'm imagining here between the Jupyter notebooks and the paper that are actually going to be very similar. And so the places that I would find most interesting to explore are precisely the places where you don't want to be describing the same thing twice, and the way in which your structures would allow you to cross-link things in a way that there was a single, effectively, source of truth, at least within the repo, describing, say, a block of code or the interpretation of a figure or such, that that you're not both writing the paper and writing documentation. You're doing it once, and that's the fact of the materials.
The curve note technology that Alan was describing earlier uses, you're familiar with MIST, markedly structured markdown, I think, which doesn't quite work as that acronym, but that's kind of their native language for composing their objects, which are more than a Jupyter notebook or Jupyter Lab notebook, in that they have exactly the kind of extra things that you need to have it be able to generate a paper that you can send as a PDF to a journal. We have hired them over the last few months to expand that, or basically to take set things up so that one can have a paper that is written in LaTeX originally, and you can sort of run an automatic converter that will convert the results of that into markedly structured markdown.
I was gonna say yeah. I was gonna say that actually doing things in Markdown is often much easier, even when you want to refer to code, because Markdown is so like flat, like your ability to declare that a particular environment is code and that it's code of a particular language and whatnot is present. And so getting things from Markdown to code is a lot easier than getting things from code to Markdown a lot of the time. But the thing about LaTeX that I think a lot of people don't use, that I think could be used a lot more, is actually just breaking things into chunks. And so you can build a LaTeX file by just pulling in a bunch of other files. I mean, and I remember doing this for my PhD thesis 10 odd years ago plus, and it ended up making a friend who gave me a template that was structured, that really chunked things down, made it so much easier. And I'm wondering also if that will enhance the reusability, because for any section that's not, say, math heavy, then within reason you're really changing very little. You're literally, you have text and it's okay, cool. Instead of a .md, it's a .tex, but you have essentially, I'm talking about something like when you chunk things down enough and they get typed, or given even if it's natural language, think of the file extensions as types, and then you can further subtype things, and you get some pretty strong interoperability when you start asserting typing and subtyping systems, because then you don't have to try to make everything that's markdown work as LaTeX or vice versa. You can say, well, things that satisfy the following criteria are, they're going to support this particular transformation. And it's been a recurring theme where there's always an emphasis towards universality, but like, because that's what is exciting and popular. But like, it turns out if you just make some minor requirements and restrictions, you can get a lot of power pretty quickly. And so anyway, it just seemed relevant in this case of transforming between doc structures and being saying, hey, this is mostly text, or this is a math proof. And just that extra metadata about the object would change which kinds of transformations you'd run it through.
Great minds think alike. I have been doing that kind of thing for some time. In particular, I found that it is very convenient when you're collaborating on a project with co-authors to, at a minimum, break it down into standalone subfiles using the subfile package in LaTeX, so that, you know, I'm in charge of the introduction and you're in charge of the conclusion, and every time either one of us makes a change, we don't have to, you know, merge into one giant big tech file. I've done some other things along those lines. In particular, I have a tendency to greatly overuse the verbatim write option in LaTeX, particularly for things like equations that I am going to use both in the main body of the text and in my slides and maybe in my appendices. And if I fix the equation, I discover a mistake, or I want to change the notation or something in one place, and then that gets verbatim written out, and the other things just import. Then I fix it everywhere, but I fix it in one single source of truth. But these are more advanced things that obviously we would not need to require for what we're offering in terms of the remark thing. So the one other point I would make about the kind of remark project is one of our, we sort of have a longer term goal, which is to make this, you know, our dream outcome would be for the standard that we're working on to be adopted by some kind of international standards body, that could say, you know, maybe it's for libraries, or maybe it's, I don't know exactly who the standard authenticators or adopters might want to be, but there are, you know, processes out there for defining standards and bodies to sort of help the standard evolve over time. And if we could produce something that was appealing for whoever it is that approves these kinds of standards, that would be our ideal outcome. And then any journal that wanted to use this technology as its submission standard would just, you know, say, oh, we're using ISO whatever protocol for the submissions.
Yep. Makes sense. I have some notes in just from this talk of concepts that came up. I'm sure there are more, but like modularity, reproducibility, object identity, actor identity, contribution history, forkability, lineage across various forks. So being able to do, it's like a different kind of contribution history, you know, internal to repo versus amongst repos. I'm sure there's more, but you know, with you talking about the kind of standards bodies buy-ins, I feel like, at least from my perspective, there's like a set of kind of high level desired requirements, like we want to positively affect the way this economy of knowledge is evolving and growing. what that means, then there's some concrete sub requirements that are like, hey, these things must be true of these objects. And then there's a question of the extent to which a particular protocol or pattern, whether it's a particular way of building repos instead of tools that you use within those repos. At that point, I would call that protocolization, where you're basically min-maxing between the expressivity and the like ease of use, right? So you don't want if too much expressivity means something can get very hard to use, but too easy to use often comes at the cost of expressivity. So, protocolization is this process of teasing out a trade-off point in those two spaces with specific requirements in mind. And so I'm kind of poking at this because I think that there probably is something that is, developable into the kind of standard that could work, and not just for economics. I mean, this is basically for computer-aided scientific work, period. And it's an adaptation or almost like an integration of the learnings of software development, version control, and just generally the fact that our information infrastructures afford us this view-based model of higher dimensional objects rather than this like hard serialization for transmission. So a lot of opportunities here. So anyway, I know we're at time, so I should let John close us out. But as far as this group is concerned, this interest group, I consider this to be kind of the point, right? To try to figure out what this looks like for science, for economics. But in a way, that's why when I wrote the topic, I tried to make sure that it wasn't just the open source economics, but it was also the economics of open source science, because I think that's really what we're digging at here.
This is lovely.
This has been an interesting conversation. Jonathan has pointed out there is an open source science interest group starting now, non-focus thing. So I suppose maybe we should go to that.
Yeah, actually, we will. So that's a product-oriented working group on the map of open source science, but we will almost definitely be continuing this conversation there as well. Beyond that, for future calls, Z, I love what you were just saying. There's a question in the chat from Victor about what might be some future topics here. And then, Z, while you're reviewing that message, Chris and Alan, I'm curious, what are other problems or things you guys might want to come back and talk about regarding remarks and adoption of reproducibility? So I've got funding models down for this type of open source tooling. Is there anything else that's just like a big high level topic very quickly?
So there is one that we have not quite worked out. So far, the remarks that we have constructed and that other people have constructed using our technology are things that can reasonably be executed, in a few minutes or at most a few hours on kind of very simple computational hardware. But there needs to be some capacity to, the thing it's most important to be able to replicate in some sense is the really big projects that require, 1,000 cores for 2 days or something like that. A strategy by which the person who is submitting something to a journal or to as a supposedly reproducible object, that person themselves has to pay for the compute cost. It seems like the only real way to go for this. I mean, the natural thing really would be for them somehow just to demonstrate that whatever the system is that they are running the code on, that everything they have done could be ported over to another system that has the same resources, and it could run in that new place with the new resources. And how exactly to structure that or to work that out is, I think, a high priority topic for us, which we haven't got very good ideas about.
Awesome. Okay, so what this is sounding to me like, I've written that one down as compute resources / funding models, that sort of thing. But we're going to be spinning up, I think, this is still tentative, but a sort of technology oriented, infrastructure oriented interest groups that's talking about the sort of the deep tech, the underlying infrastructure that will enable open science practices, reproducibility being one of those critical practices. These topics sound very relevant to that interest group. Other things there are data storage and management, peer review processes and infrastructure for that, scientific society, like management and community infrastructure. So I think having those discussions there makes a lot of sense in the future. So I'll definitely keep you in the loop as we get that interest group running. Hopefully by September. Not entirely sure yet, but yeah, I think those are going to be a lot of really fun discussions.
So in particular, scientific professional associations are very interesting to me right now as the incoming president of such an association. And I've been hoping that I could use my presidency to sort of do a bunch of these kinds of things. And so hearing what the things are that would be the ones that we should do.
Awesome. Yes.
There might also be an interesting overlap there with some of the knowledge organization infrastructure research that's happening in MetaGov. I don't know, John, you've seen some of that. I might chat with you, and Chris, is that in the future if you're interested. And I think, John, I'm gonna send there's at least one of my team members who would be a good fit for that infrastructure group who leads on a lot of those initiatives. I know we're way over, but you wanted me to reply briefly to the comments from Victor, I think. I have 2 quick thoughts, and then maybe we should probably let people run.
Yeah, go ahead.
So the first question about creating a list of mathematics and scientific methodologies other than economics enhanced by AI, that actually does sort of fit into this question of kind of knowledge infrastructure. I've weirdly enough found the library science world to be somewhat interesting because the question of maintaining information about information is not new. And what ends up happening with AI being able to enhance things, at least in my experience, has come down to whether or not those things are organized in a way that you can point AI at it such that the resulting applications of AI produce sort of sensible and reproducible results, like reliable results. And the effort to organize the information that you are applying the AI to ends up being a defining characterization, like a defining element of whether the AI being applied to that thing ends up being useful. And obviously that could be its own long conversation. And then on the applied econ, I have a maybe less happy thought. Like in terms of hiring people, I've hired over the years personally several people with economics degrees, including, I guess, 2.5 PhDs. I'll say half for the third person because their degree, I believe, was in industrial organization or something on the boundary of industrial engineering, which is still very economics heavy, but a bit more engineering-y. But the three people with economics or economics adjacent degrees all really got hired for that domain expertise cross some practical engineering experience. And in my at least for me, if I'm hiring for people to do like projects, to do like work, I need them to, I view economics itself as a domain expertise, not like a technical proficiency. And so it's always an and. And I don't know whether that's just like maturing the field of economics so that and is much more common, which kind of speaks to what you guys have been talking about. But at least within the current job market, yeah, I can only really assume an economics degree implies domain expertise and that I have to find some other way of validating their like professional competencies.
Absolutely true. I mean, one of the real struggles for getting this whole project working is precisely the scarcity of people who, like Alan, have talents in both areas. So very much on the same page with you on that.
All right. So on that, we'll wrap this one up. You guys should definitely come join the Moss call the Map of Open Source Science interest group. Well, this is another good discussion, but it's not going to beat this one. This is now my favorite interest group. So I'll follow up, Chris, L, and Z. We'll maybe make an email thread regarding the technology group and see what we can do there. Otherwise, thanks y'all for a great discussion and the walkthrough of remarks. This was amazing.
Thank you.
Thanks all.
Bye.